Here's another one. Cosine x plus 1 equals what? Sine x. Ooh, what are you going to do here? Well, first off, cosine x plus 1, if I square both sides, right, I can do that, right? They're still both equal, right? So now if I square both sides, I have cosine squared x plus 2 cosine x plus 1 equals what? Sine squared x. And now I can change sine squared into a cosine 1 minus cosine x. And what I'm going to do now is this. I'm going to take this cosine squared and add it to each side to move it over here. And I'm going to subtract 1 from each side. I minus 1 and add that. I get 2 cosine squared x plus 2 equals cosine x equals 0. I might go ahead and do this. Pull that 2 cosine x out, because that's common. And that leaves you a cosine x plus 1 equals 0. Ooh, okay. And then right here, 2 cosine x equals 0. Well, divide by 2. Where's cosine x equals 0? At pi over 2 or 3 pi over 2. It does occur 2 times where cosine is 0. And where's cosine? Then don't forget your plus or minus what? 2n pi. Here I'm going to what? Minus 1. Where's cosine equal negative 1? At pi. And that's plus or minus what? Your 2n pi also. So pi over 2 plus or minus n pi. 3 pi over 2 plus or minus 2n pi. And pi plus or minus 2n pi. Notice though, I made them into things I could work with. And when I couldn't think of something to make it into, I could square both sides and then use a Pythagorean identity to kind of make things a little bit simpler and easier.